Bismillahirrahmanirrahim. Quote of the day. You will face many defeats in life, but never let yourself be defeated by Maya Angelou. I am Dr. Ahmad Wahid Khan, PGR Community Medicine, KEMU, under the kind supervision of Professor Dr. Saira Afzal, Chairperson and HOD of Community Medicine Department, King Edward Medical University, Lahore. Today, my topic of presentation is Pearson correlation, Spearman correlation. Learning outlines, introduction, learning objectives, correlation and its type, Pearson and Spearman correlations, recent advances and MCQs. Learning objectives. At the end of this presentation, the participants would be able to describe the introduction of correlation, compute their values, Pearson product moment correlation coefficient, Spearman correlation, their advantages and disadvantages. Introduction. Correlation. Correlation is a statistical method used to determine whether a linear relationship between variables exists, a numerical measure to determine whether two or more variables are linearly related, and to determine the strength of the relationship between or among the variables. This measure is called a correlation coefficient. There are two types of correlation, positive correlation and negative correlation. First, we will discuss about positive correlation. A positive correlation exists when both variables increases or decreases at the same time. For example, a person's height and weight are related and the relationship is positive. Since the taller a person is, generally the more the person weight. Positive correlation in some cases, increase in value of one variable is associated with the increase in value of other variable, or decrease in value of one variable is associated with decrease in value of other variables. Correlation between these variable is said to be positive. Now we discuss negative correlation. In a negative relationship, as one variable increases, the other variable decreases and vice versa. For example, if you measure the strength of the people over 60 years of age, you will find that as age increases, strength generally decreases. The word generally is used here because there are exceptions. In some situation, increase in the value of one variable is accompanied by decrease in value of other variable, and decrease in value of one variable is accompanied by increase in value of other variable. Correlation between these two variables is said to be negative. There are some examples of positive and negative correlation. Positive correlation, a relationship between sale of cold drinks and temperature, the relation between DUIs and accidents. And in the example of negative correlation, there is a relationship between alcohol consumption and driving ability, and the relationship between supply and price of commodity. Pearson product moment correlation coefficient, named after statistician Carl Pearson, who pioneered the research in this area. The correlation coefficient computed from the sample data measures the strength and direction of a linear relationship between two quantitative variables. The symbol for the sample correlation coefficient is R. The symbol for the population correlation coefficient is R, Greek letter rho. Range of the correlation coefficient. The range of the correlation coefficient is from negative 1 to positive 1. If there is a strong positive linear relationship between the variables, the value of R will be close to negative 1. If there is a strong negative linear relationship between the variables, the value of R will be close to positive 1. When there is no relationship between the variables or only a weak relationship, the value of R will be close to 0. The relationship between the correlation coefficient and a scatter plot. The graph in the figure show the relationship between the correlation coefficients and their corresponding scatter plots. Notice that as the value of the correlation coefficient increases from 0 to positive 1, part A, B, and C, data value become closer to an increasingly strong relationship. As the value of the correlation coefficient decreases from 0 to -1, part D, E, and F, the data values also become closer to a straight line. Again, this suggests a strong relationship, as shown in the figures. There are several ways to compute the value of the correlation coefficient. One method is to use the formula shown here. R is equal to n into sum of x into y minus sum of x into sum of y divided by square root n into sum of x square minus sum of x square bracket close, then n into sum of y square minus sum of y square, where n is the number of data pairs. Now we see the example. The car rental companies compute the correlation coefficient for the data in the example as shown in the table. There are six company and there are X cars, revenue is Y as shown in the table. Now solution, first we calculate the sum of total of X, then calculate the sum of total of Y. Find X square and its sum total, find Y square and its sum total, calculate X into Y and its sum total, calculate N sum of X and Y, then apply to a formula where N is the number of pair of score or number of variables. Here N is 6. The correlation coefficient suggests a strong relationship between the number of the car a rental agency has and its annual revenue. Now we discuss the strength and limitations of Pearson correlation. Strength, there it is always useful to plot a scattergram to see if there are any outliers. It is not influenced by extreme values. It is easy to understand. It gives us the exact measure of the degree of correlation between the two variables. Limitations, it only measures how closely the two variables approximate a straight line. It does not validity measure the strength of a non-linear relationship. It cannot be applied to qualitative data. Pharmaceutical application of Pearson correlation. It is mainly used in the analytical method validation to render the method which result with precise and accurate values. It is used in the early stage of drug development. Number three, it is used to analyze the relationship between two variables like concentration versus absorption and dose versus therapeutic effects. Now we discuss about the Spearman correlation. Definition: the Spearman's rank coefficient of a correlation is a non-parametric measure of rank correlation, statistical dependence of ranking between two variables. Name after Charles Spearman, it is often denoted by the Greek letter P rho and it is primarily used for data analysis. It measures the strength and direction of the association between two rank variables. Formula for computing the Spearman rank correlation coefficient is Rs is equal to 1 minus 6 sum of d square divided by n square into n square minus 1, where d is the difference in ranks and n is the number of data pairs. The steps for finding and testing the Spearman rank correlation coefficient are given in the procedure table. Now, step one, first we state the hypothesis. Step two is rank each data set. Step three, subtract the rankings x1 minus x2. Step four, square the differences. Step five is find the sum of the squares. Step six is substitute in the formula. Rs is equal to 1 minus 6 sum of d square divided by n into n square minus 1, where d is the difference in ranks and n is the number of pairs of data. Step 7 is find the critical values. Step 8 is make the decision, and step 9 is summarize the results. For example, consider the score of 5 students in maths and science that are mentioned in the table. Solution is first step is to create a table for the given data as shown in the figure. Then step 2 is rank both the data in descending order. The highest marks will get a rank of 1 and the lowest mark will get a rank of 5. Step 3, calculate the difference between ranks D and the square value of D. Step 4 is add all your D square values. Step 5, insert these values into the formula as given. The spearman rank correlation for the given data is 0.3. The value is near 0, which means that there is a weak correlation between two ranks. Advantages and disadvantages. First, we discuss the advantages. There are few advantages of Spearman correlation. Less sensitive to bias due to the effect of outliers can be used to reduce the weight of outliers. Large distances get treated as a one rank difference. Does not require assumption of normality when the intervals between data points are problematic, it is advisable to study the ranking rather than the actual values. And there is one disadvantage, calculation may become tedious. Additionally, ties are important and must be factored into computation. Now it's time for recent advances. Comparison of values of Pearson and Spearman correlation coefficient on the same set of data. Abstract Spearman's rank correlation coefficient is a non-parametric ranked statistic proposed by Charles Spearman as a measure of the strength of an association between two variables. It is measure of a monotone association that is used when the distribution of data makes Pearson correlation coefficient undesirable or misleading. Spearman coefficient is not a measure of the linear relationship between two variables as some statisticians declare. It assesses how well an arbitrary monotonic function can describe a relationship between two variables without making any assumption about the frequency distribution of the variable. Un- Unlike Pearson product moment correlation coefficient, it does not require the assumption that the relationship between the variable is linear, nor does it require the variable to be measured on interval scale. It can be used for the variable measured at the ordinary level. The idea of the paper is to compare the values of Pearson product moment correlation coefficient and Spearman rank correlation coefficient as well as their statistical significance for different set of data original for Pearson coefficient and rank data for Spearman coefficient describing regional indices of socio-economic development. The second article is perspective article on the use of the Pearson correlation coefficient for model evaluation in genome-wide prediction. Abstract. The large number of markers in genome-wide prediction demands the use of method with regularization and model comparison based on some hold-out test prediction error measures. In quantitative genetic, it is common practice to calculate the Pearson correlation coefficient as a standardized measure of the predictive accuracy of a model. Based on argument from the bias variance trade-off theory in statistical learning, we show that shrinkage of the regression coefficient reduces the prediction mean squared error by introducing model bias compared with the ordinary least square method. We also show the lasso and the adaptive lasso can reduce the model bias prediction MSC by adding model variance in an application of ridge regression, the lasso and lasso to a simulated example based on result for 9,723 SNPs and 3,226 individual. The best model selected was the lasso when R square was used as a measure. However, when model selection was based on the test MSC and coefficient of determination R square, the LSO proved to be the best method. Hence, use of R square may lead to selection of the wrong model and therefore also non-optimal ranking of phenotype prediction and genomic breeding values. Instead, we propose use of the test MSC for model selection and R square as a standardized measure of the accuracy. Now it's time for MCQs. MCQ number one. If the relationship between two variables is directly proportional, then the correlation would be A 0, B positive, C negative, D both positive negative, and E is null.
B.
B. Yes, the answer is B. Correct answer. Question number two. Compute the value of the correlation coefficient for the data obtained in the study of the number of absence and the final grade of the 7 students in the static class given in the table. Option A is minus 0.944. Option B is plus 0.944. Option C is plus 0.9873. D is minus 0.234 and E is 1.00 and 0.
D.
No, the answer is A. Here is the solution for this question. We calculate through the formula and putting the values. Question number three, if the relationship between two variables is indirectly proportional, then the correlation would be A is 0, B is positive, C is negative, D is both positive, negative, and E is null.
C.
Negative.
So negative, yes, C is the correct answer. Question number four, a correlation coefficient R consists of two parts, a sign and a numerical value. What is the range of values possible for R? A is 1 to 2, B is negative 1 to positive 1, C is positive 1 to negative 1, and D is 0 to positive 1, E is minus 2 to positive 1.
C.
No, answer is B as we discussed in the presentation earlier. Negative 1 to positive 1. Question number five. What correlation would you expect in the amount of rubber on tires and the number of miles they have been driven? A, no correlation. B is negative correlation. C is positive correlation. D is spearman correlation. And E is Pearson correlation.
D.
B. B.
Yes, the answer is B, negative correlation. Question number six. To see the relationship between the heights of tall trees and their diameters, you find the following data for the diameters in inches of the tree at 4.5 feet from the ground and corresponding heights in feet. What type of non-parametric analysis could be used? A is Spearman rank correlation analysis, B is Pearson correlation, C is ANOVA, D is ANCOVA analysis, and E is statistical analysis.
B.
The answer is A,
Army.
Spearman rank correlation analysis. Question number seven. The following are data for 12 individual daily sodium intake and their systolic blood pressure reading as shown in the table. A researcher investigator is interested in learning how strong the association is between these variables and how well we can predict the blood pressure from the sodium intake compute R. Options are A is 1.988, B is 0.919, C is negative 0.987, D is 1.874, E is 0.986. The correct option is B 0.919. Here is the solution for this MCQ. Now, question number 8. Richard Doll, a British investigator of the relationship between smoking and a lung cancer, compiled the following information on per capita cigarette consumption in 1930 and the lung cancer 20 years later. In 1950, for a number of countries, as shown below, compute the R and R squares uh, of this data. Option A is r is equal to 0.7373. R square is 0.54. Option B is r is equal to 0.9873. R square is equal to 0.97. C, r is equal to 0.2365. R square is 0.05. D is r is equal to 0.9873. R square is 0.97. And option E is r is equal to 0.1276. R square is equal to 0.01. The,
D.
the correct option for this question is A. R is equal to 0.7373. Here is the solution for this MCQ. Now, question number 9. A correlation is unaffected by the change of A, origin, B, scale, C, measurement error, D, the amount of variability in the data, and E is characteristic of the sample.
B.
B, yes, it's B. The correlation is unaffected by the change of scale. Question number 10. If six handwritings were ranked by two judges in a competition, the ranking shown in the table, then the value of the Spearman rank correlation is A 1, B 2, C 0.5, D is -1, E is -0.5.
C.
No, the correct answer is D -1. Here is the solution for this MCQ. This is the key. These are the references through which this presentation has been made. And thank you. Kindly like and subscribe our YouTube channel.
Thank you very much. A very nice presentation, Dr.